This is what you need to know for the second half of the chapter. So we're going to have a test. It's 50 points, and it's over 9.4 to 9.6. So make sure you know, this must have just fell down here from the PowerPoint. So we have been studying transformations. So there's two types of transformations. There are isometries. So isometries is when the figures are congruent, and dilation. So a dilation is a type of transformation where it is not congruent. So congruent is the same size and same shape. So definitely with a dilation, it's the same shape, but it might not be the same size. Whereas all of these are the same shape and same size. So there are isometries that preserve orientation. So preserve means it stays the same. And then there are isometries that do not preserve orientation. So reflections and glide reflections are the ones where the orientation is not the same. So what I mean by orientation is if you have a heart and the dot on the heart is on the right hand side and you reflect it, the heart's going to be over here, but now the dot's going to be on the left hand side. So that's what it means when the orientation is not preserved. So over here, if you have a translation and the heart and the dot was on the right hand side and then you just shifted it, the heart still stays on the right hand side. Same with the rotation. If you had a heart and then you turned it, the circle would still be on the right hand side. So make sure you know the four types of symmetry or isometries. Here are the four types. Isometries are congruent figures. Make sure you know which ones do not preserve orientation and which ones do preserve orientation. And know that a dilation is not a isometry. So in this example, is the orientation preserved? Is the orientation the same? So look at these two footprints right here. Well, this big toe is on the right hand side and this big toe is on the left hand side. So we know that it's going to be a reflection. So to check to see if it's a glide reflection, this foot should have been right across from the other foot, but it's not. It's been shifted. So because it's reflected and it's been translated, so whenever you have something that's reflection and a translation, then the answer is going to be a glide reflection. So to answer the first part, is the orientation preserved? No. Name the isometry. It's a glide reflection. And then is the orientation preserved here? So yes. So if I'm going to look at this arrow right here, and this skinny part is on the left hand side, and over here this skinny part's on the left hand side. So yes, the orientation is the same, and it's just been rotated. So in this picture, is the orientation preserved? So the tail is on the left-hand side, but the tail over here is on the right-hand side. So no, it's not preserved. Name the isometry. So again, the types of isometry are reflections, glide reflections, rotations, and translations. So it's got to either be a glide reflection or reflection. So since this is right across from each other, this cat hasn't been shifted, the isometry is a reflection. And then, is this orientation preserved? So the eye's on the left-hand side, the I prime's on the left-hand side. The pre-image of the R is on the right-hand side. R prime is on the right-hand side. So yes, the orientation is preserved. It's the same. Name the isometry. So it's just been shifted. It hasn't been rotated at all. It's been shifted. So this is a translation. Okay, is the orientation preserved on here? So let's look at these letters. The yellow figure, the pre-image. goes ABC. So ABC is counterclockwise, but over here A, B prime, C prime is clockwise. So because it went from counterclockwise to clockwise, the orientation is different. So no, it's not preserved. And I can't draw a direct line of reflection. So if I take this yellow figure and if I would shift it over here, so this is not going to be the best drawing here, but it would look something like this, CBA, if I shifted this over. So this figure right here is a reflection of this figure, but it's just been shifted, so the yellow is shifted over. So this is a glide reflection. The orientation is different, so it's a reflection and then it's been shifted. Okay, what is the scale factor? So to calculate the scale factor, you do the image divided by the pre-image. So the image is the one with the prime. So if C prime has coordinates of 0, 4, and C has coordinates of 0, 2, we just multiply C by 2. So the coordinate for this is 4, because that's the image. 4 divided by 2 is 2, so the scale factor is 2. On the quiz, I noticed a couple people, 1/3 was a scale factor. You don't write 0.3. 1/3 is not equal to 0.3. So you should either have done 0.3 repeating or just keep it as 1/3. Okay, next one, what is the angle of rotation of each? All three of these figures have rotational symmetry. So rotational symmetry is if you can turn it within 360 degrees and it's the exact same figure. So if I turn this one 90 degrees, it looks like something like this. But if I turn it 180 degrees, it'll be upside down, which is the same thing as right side up. So this one there's basically two distinct parts of this. So I did 360 divided by 2 is 180 degrees. Don't forget your degree symbol. This one, there's 3 parts to it, so I did 360 divided by 3, which is 120 degrees. This one, there are 5 parts to it, so I do 360 divided by 5, it's a 5, which is 72 degrees. What's the angle of rotation on this figure? I see 4 parts that are all the same. All of these quadrants are the same. So this has 360 divided by 4 is 90 degrees. Which isometry is created from reflecting a figure over 2 intersecting lines? So if you had 2 lines and you had a figure like this and you reflected it over L then M, what would the resultant be? So if I reflect this over L, it would be like this. The orientation has changed. Now if I reflect it over the M, the orientation changes again. So this one, the dots on the right, the dots on the right. Isometry from 2 intersecting lines is a rotation. You can know that too without drawing a picture and just know that 2 intersecting lines is going to make the rotation. 2 parallel lines would be, so here's my dot, it's on the top, then it's on the bottom. Then I take this and I reflect it over the bottom line, then it's on the top. So from here to here is a translation. So 2 parallel lines is a translation. Which isometry is created by reflecting a figure and then translating it? That's the definition of a glide reflection. If the isometry below is a reflection, fill in the points on the image. So where is B right here? If this is my line of reflection, then B prime has to be right here. A prime has to be right here. C prime is right here and D prime is right here. It's been flipped. So if I look at A, B, C, D goes clockwise, A, B, C, D goes the other way, counterclockwise. The figure at right is a label of the image after a glide. So a glide, again, the orientation is changed. So it's been shifted, it's been reflected. So it would be right here, B prime, A prime, C prime, D prime, and then it's been shifted. That's the definition of a glide. So this would be B double prime, A double prime, C double prime, D double prime. So the orientation is opposite for a glide. Now this figure's been rotated 180, so now you got to think about what it would be if it was 180. So this C would pivot and be right here, C prime. This D would be with the D prime. The A is next to the D, and the B is all the way over here. So think about a car turning a corner. The figure at right is the image after a translation. So a translator just shifted it. So it's just going to be A prime, B prime, D prime, C prime. List the coordinates after it's reflected over M. So I'm going to move this P over 2 spots. So P prime is going to be at 7, 8. I'm going to move this Q over 2 spots on the other side. So Q prime is going to be at 7, 2. Make sure you write parentheses with your order pairs. R prime is going to be at, move it over 4, move it over 4. It's going to be at 9, 6. So I'm going to draw my triangle in. And then make sure you label the coordinates, R prime, Q prime. And list the coordinates of the image after it's reflected over y equals 1. So y equals 1 is a horizontal line, right here. So we're going to do the same thing. So S is going to be 1 above, 1 below. So S prime is going to be at 1, 0. Okay, G, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. G prime is going to be at 4, and then down 1, 2, 3, 4. 4, 4. Or 4, negative 4, sorry. And then V, down 2, down 2. Or up 2, down 2. V prime is going to be at 1, 2, 3, 4, 5, 6, 6, negative 1.